Hi, good afternoon. This is sdora3 and I'm here to present my final presentation for activity classification using MHI. In the interest of time, I'll briefly walk you through the algorithm. We'll talk about the results that I got from prediction. We'll talk about a scenario wherein my code doesn't work, and we'll discuss briefly on improvement ideas. So in line with the instruction sets and paper and lecture, essentially I have, for each of the known motions, I have identified the start frame, duration, some values of theta and threshold, which I got through trial and error. Now for each of those input videos, knowing the motion, I run them to identify a set of binary difference images from which I calculate the MEI and the MHI. And based on the MEI and MHI, I use them to calculate my hue moments, the central and the scale invariant. The scale invariant then is used to train my model, which essentially uses OpenCV's k-nearest. To show you some of the outcome or the MEI image that I got from training the model, on the top right here you can see the MEI image for hand clapping, and here you can see the MEI image for hand waving. Moving on to prediction, for a given input, I run it through all the thresholds that I had calculated earlier, and I obtain hue moments for each one of them. Once I get the hue moment, I run them through the k-nearest to identify the nearest known motion classification, and that's something is what I identify as the motion for the input. We were given one video to train our model, and towards running it through all different set of videos, I have run for each of the motions around 100 videos, overall 600, and as you can see, I've had a healthy success classifying accurately with over 60% accuracy. Couple of scenarios where my code doesn't work is when it gets confused in terms of the MEI images. As you can see, this is a set of 6 MEI images for a hand clapping video. The 6 MEI images corresponds to different theta and threshold values. However, if you see for more than 50% of them, the MEI image corresponds more towards hand waving instead of hand clapping, which is what my code identifies it as, although incorrectly. That brings me to the improvement potential. I believe having more than one camera to train would definitely improve the accuracy of my model. In addition, what I have seen is having a different value of theta and threshold significantly change the binary image, and a careful choose or probably a correction of the theta or threshold will also help improve my accuracy. Also, there are certain actions like a jogging and running which closely resemble each other, and has caused a lot of confusion in terms of in my model, essentially to predict properly. And a better algorithm to differentiate between them would be a great improvement. Finally, there are many state-of-the-art methods which have a great accuracy, and using optical flow motion, timed MEI and gradients, I believe we can further improve the code. Thank you.